Question number 5. For t greater than 0, the position of a particle moving along the x-axis is given by this equation. So this is the position function, which remember, if you can think back to particle motion, position is like the original function, velocity is the derivative, so the first derivative, and acceleration is the derivative of that, which is the second derivative. It says, what is the velocity of the particle? So we're trying to find the velocity of a particle, or of this particle, at the point where the acceleration is first equal to 0. So I need to figure out where the acceleration is first equal to 0, and when I figure out what value or what time that would be, plug that back into the velocity function in order to figure out what the velocity was at that point. So in order to figure out where the acceleration was first equal to 0, I actually need to go through and find the second derivative of this. So the first derivative, x prime of t, which is actually giving me the velocity function. The derivative of cosine of t is negative sine of t, and the derivative of negative sine of t is negative cosine of t. And again, in order to figure out where the acceleration is 0, I have to go one more time. So I need to find the derivative of that. So v prime of t, which is the acceleration function. So the derivative of negative sine of t is negative cosine of t, and the derivative of negative cosine of t is positive sine of t. And we're looking for where this equals 0 for the first time after 0. So we looked at a problem similar to this previously, and we taught you that little trick, or I should say I taught you that little trick about the fact that when it's multiple trigonometric functions, to combine it into one, you can try to isolate one on one side and one on the other, and then divide. So I'm going to move negative cosine of t over to the left-hand side, over to the right-hand side, so that I get sine of t equals positive cosine of t. And I'm going to divide both sides by cosine of t. The left-hand side, sine divided by cosine, is tangent. And the right-hand side, cosine divided by cosine, is 1. So again, I'm looking for what value of t would make the arctangent of 1, or what arctangent of 1, what equals that, and that would be t. Or in other words, thinking back to this equation, what value of t would make tangent equal to 1? And the answer to this is actually the same as that earlier problem we were working on. So the first value of t that makes tangent equal to 1 is actually pi over 4. That's the first value after 0, I should say. So the first value that we're looking at would be t equals pi over 4. And so that's the t value that it occurs at. But remember, the question doesn't want to know what the t value is. The question wants to know what is the velocity of the particle at this point. So once I know what time has elapsed in order for this to be true, I need to go back and find the velocity at pi over 4. So essentially, I'm going to plug in pi over 4 back into my velocity function. So I'm going to erase all this really quick. And then I'm going to plug pi over 4 back into that function. So I have v of pi over 4 equals negative sine of pi over 4 minus cosine of pi over 4. And sine of pi over 4 is root 2 over 2, so that's negative root 2 over 2, minus cosine of pi over 4 is also root 2 over 2. So when I add these together, I have negative root 2 over 2 minus root 2 over 2, that's negative 2 root 2 over 2. Lots of 2's. And that simplifies to negative radical 2, which is answer choice A.